So I want to thank everyone for joining today on our hybrid positioning surveying and magnet field. I'm Jim Martin, the Business Development Manager Director for Topcon Solution Store. And with me, I have Mark Roskin, our Survey Sales Manager out of our Carroll Stream office. Mark and I have known each other for 20 plus years. We've both been in this industry longer than we care to remember. I joked last time that Mark helped lay out the pyramids in Egypt, and he corrected me. It was actually the Colosseum in Rome. So we've both been doing this for a long, long time, and have seen this technology change from transits and chains now through GPS and robots. So a little bit about Topcon Solution Store. We are the retail division of the Topcon Positioning System. So we are a wholly owned subsidiary of Topcon. We are a complete solutions provider. All of the measuring and control hardware systems. We sell surveying instruments. We sell machine control, the automates dozers, motor graders, excavators. We also are a platinum partner with Autodesk and a platinum partner with Bluebeam. So we have complete office solutions and have complete knowledge of how to make the office solutions and the field solutions work together. With that includes our industry-leading training and technical support. We do field troubleshooting. We have local service and repair. And then in all of our office, we have the widest range of everyday field supplies and accessories. So we have 13 retail stores across the U.S. stretching from Seattle, Washington, over outside of Boston, Massachusetts, and all these spaces in between, covering 20 different states, including Washington, D.C., and over 180 employees. Training is a key portion of our solution. So we fully know that buying hardware from us, buying software for us does no good unless your employees know how to use that equipment. So we have full training classes from Magnet Field, Pocket 3D, 3D MC, all of the Autodesk products, and Bluebeam. Plus, we have a full technical support team that is available from 7 a.m. on the East Coast to 5 p.m. on the West Coast. And then plus, each one of our locations has a full service department for doing Topcon warranty repairs and servicing any other brands of surveying equipment. So let's talk about what we're going to do today. We're going to talk about really what is hybrid positioning. What does that mean when we say that? Talk about all the different components of a hybrid positioning system. Talk about why you would use hybrid positioning. What is the advantage of using it? We'll talk about some of the functions and terminology that you'll see in Magnet Field. Then go through how to configure Magnet Field for hybrid. And then last, I've got a video of me actually going out and using hybrid in the field. So with that, I'm going to pass this over to Mark Roskin. He's going to go through all of our agenda items and really talk about hybrid. So Mark, it's all yours.
Thank you very much, Jim. I appreciate it. And I'm very excited for this topic here today. We want to explain to everyone what the features are of hybrid and the benefits that it brings. So the definition of hybrid basically is the composing of mixed parts or the combining of two different elements. What Topcon hybrid positioning is, it's our overall term used to describe several new features of utilizing GPS positioning information to supplement optical instrument measurements. And it will enhance your system performance and dramatically increase the productivity and also the workflow. We're seamlessly putting together information from GPS and robotic technology to provide positions. As many know, that GPS and robotics each have their benefits, and they are a different tool to use for the various positioning solutions that one needs out in the field. Robotics is fantastic when you're talking about line of sight and the applications that robotics provide, and GPS, view to the sky, that is another fantastic technology that most people have as well today. But we are putting hybrid together for all of those out there that are unfamiliar with it to permits somebody to get a seamless position using either one of those technologies in one solution. So if you would, thank you. So the system utilizes both GNSS equipment and robotic technology, and it does dramatically improve the productivity. What a lot of people do today, they take their GPS out, they will go and shoot control points in. They will do as much as they can with GPS, and for whatever reason, they're going to have to put their GPS away and pull out a robotic to do additional measurements on a job site. So they're switching over at some point in time to take and use either one of those tools from their toolkit and apply them to the task at hand. With our hybrid, and only available in the Magnet Field family of software, we have written, our software developers have written some tremendous programming into the software that is very unique for us, and will let the users use both technologies at the same time, thus calling it hybrid. It does require the purchase of a hybrid positioning module or a solutions product. As those that are out there that are using Topcon or Sakia robotics and GPS, they already have those modules, but the requirement to use hybrid is that they get the hybrid module added to either an existing perpetual license, or if they have solutions, then they already have hybrid and they just need to be educated on how to use it and trained and take advantage of hybrid. So hybrid offers a faster reacquisition of prisms rather than the older types of quick lock features that the Topcon RC units in the past have offered. And so we're able to reacquire the prisms now with one button hybrid lock, and that dog whistle will permit the instrument to lock back on the prism within a matter of a second or two, rather than the 7 or 8 seconds that our older RC units would provide reacquisition. So today's components of Topcon hybrid positioning are as follows. I've put together a sampling of a hybrid system that we have sold and supported, trained on in the past. And what we have is our GT series, the 1200 series, and in this case, the 3-second robot is a fine instrument for all classifications of surveying optically, and an FC6000 field controller, which is our current model. And there's options to have it with or without extended range Bluetooth. We recommend the extended range Bluetooth for hybrid applications. And so that is what we would be putting together if someone asked for a Topcon hybrid system. Of course, a pull bracket. You can get Magnet Field Solutions 12 months. That's a yearly license that includes every module that Topcon Magnet Field has, which is robotics, GPS, hybrid, roads, optical, GIS, GPS. And so just that's a 12-month subscription license. That also includes Magnet Enterprise as well. So Enterprise is our exchange cloud-based solution to transfer data from the office to the field and back again, without having to go to a physical location or file transfer in other ways. And then Magnet Office Tools, that's the program with which one can edit the raw data, whether it's the GPS or robotic raw data. You can convert that to a variety of different file formats, generate some customized reports, as well as help develop your code library for use out in the field and making your quick codes or customized code library. The adapter, which goes between the prism and the GNSS receiver, and in magnet field, when you use that adapter for hybrid, under the engine in magnet field, we have the offset between the center of the prism and the bottom of the mount of the GPS, so that it's very transparent as you switch from robotics to GPS. And just simply reading whatever the rod height is will be for either GPS or robotic, doesn't matter, with that adapter and using hybrid. We're also recommending one of our robotic wood fiberglass tripods with the quick release clamps on them. And then, of course, one of our current Topcon receivers. Two of those three are all satellites, the Hyper HR and the Hyper VR. Either one of those, you can get all satellites in view used in your solution, and as well as tilt. The Hyper SR, a great entry-level receiver for network solutions, and that would be a very nice receiver to be putting on top. All small in stature, makes the rod very lightweight. Then you're going to, of course, use a specialized robotic rod calibrated to our system, along with the 360-degree prism, and then a recommended Topcon hybrid hard case. That hard case houses the robotic, the GPS receiver, any one of those three that you see. The cutout is configured to have any one of those three receivers in the case. It houses the prism, the data collector, a battery charger, and a couple of batteries for your system. Very nice package. One case. Others that are out there, you still have multiple cases. This is a very smart, intelligent way to bring your hybrid system out. It also includes carry straps. As far as hybrid goes, Sakia is also a company that Topcon owns, and Sakia has their own hybrid positioning technology as well. I'm showing an example of a 5-second instrument, IX605, and either one of the robotic systems, whether they're Topcon or Sakia, have 6 different options for robotics. So what you see is just a fair example of a current hybrid positioning system from Sakia here, or the Topcon that I talked about. Much of the other pieces in the Sakia hybrid positioning system are very, very same. On this particular example, a very popular GNSS receiver is the Sakia GCX3 with soft case. That's nicknamed the Bullet, and that is an extremely small GNSS network solution that we offer that is very popular. And as you can see, we have the Sakia in this illustration along with a SHC 6000 field controller, which is identical to that of the FC 6000 controller. So what other types of ways can we do hybrid surveying? Anybody out there that has an existing Topcon robot or a legacy robot or a Sakia can utilize hybrid. So the Topcon robotics, such as the GPT 9000, 900, the QS stations, which are the quick stations, the PS series or the power stations, and Sakia's sister robotics, in some form or another, they can be modified and updated to accept hybrid positioning technologies. And on the older instruments, in both, we can put a Bluetooth, a long-range Bluetooth adapter via cable to the base of those instruments in order to qualify them for hybrid surveying. And with a little bit of updates on them, they are available for use in hybrid as well. Another solution besides having a long-range Bluetooth adapter plugged into the port of those older instruments is actually in magnet field. When you go to the connections configuration of your survey system, you'll see an option where we can actually communicate with the GPS receiver in order to utilize hybrid. So all current and legacy robots are in play when one is considering using hybrid. And so when we're using hybrid, we have our Robotic Total Station that is, in fact, using the data collector for communications for hybrid, and the Topcon FC6000 or the SHC6000 and the older Teslas with Bluetooth in them, those are going to be what the range of the hybrid system and the robot are going to have. So as an example, we have the FC6000 or the most recent model, the FC5000, the older collector. You could get between 600 and 1800 feet. The 1800 feet is going to be when you do have the extended range Bluetooth, either ordered with your controller, or if you have the 5000 or 6000 already and don't have the extended range Bluetooth, you'll get 600. But if you wish to have yours updated, we do have the capabilities of installing an extended range Bluetooth for those that have existing controllers that do not. The older data collectors like the Tesla or the Mesa, they do not have the capabilities and are saddled with just simply 800 to 900 foot range. So what sorts of GNSS receivers can be used? Quite honestly, all of them. And the biggest subject of note on there is going to be the weight of the rods become a little bit heavy with some of the older receivers, as they were not developed at the time hybrid has become so wildly popular. So the smaller receivers, the latest models, they're the ones that we want to be promoting people to get and move forward. So the data collectors that we see on their field controllers, the Tesla on top, the Mesa, and the FC5000 or 6000, these are all equipped with some degree of GPS receivers built into them. And if one were to want to use hybrid and not have an external GPS receiver, these options work fantastic for hybrid lock. Hybrid lock is basically the dog whistle, and the various degrees of GPS receivers inside them make them a good option for calling the instrument to you, just simply using the GPS inside these receivers, inside the controllers. So in moving on with, what quality of GNSS positions dictate the quality of the hybrid solution? Inside those receivers, as I just said, it's utilizing the NEMA data stream from the internal GPS, whether it's the 5000, the Tesla, the Mesa, and other models of the data collectors, the FC500 and the Archer 2. They have a accuracy rating with a differential correction of plus or minus, let's say 1 to 3 meters. So they can be as inaccurate as 15 feet, but usable in hybrid, and obviously it doesn't require a major purchase of GPS equipment to use the dog whistle. But in doing this hybrid switch, not the best option. The other option here we also have is taking one of our Topcon receivers, the current model, the Hyper SR. That's scalable, so one could buy a Hyper SR with L1 only active, and that would use a DGPS solution either through SBAS or using a TopNet Live DGPS correction. And what we've seen is you can get accuracy with that as a hybrid solution, a hybrid lock solution. I've seen it get down to about 1/10 of a foot. Generally speaking, I will tell people it's sub foot for that sort of correction. So it's better than the data collectors GPS chipset for hybrid lock. The last one is the most popular that we sell, and that is the RTK differential solution based on a base rover combination that uses UHF for spread spectrum radios or long link Bluetooth to communicate from the base to the rover, and putting that rover on top of the prism. You'll get centimeter precision. Network RTK, we're generally, if we're using TopNet Live or others, real-time RTK network solution, you're at about 1 centimeter to 2 centimeters on that network RTK solution. And then lastly, Magnet Relay. That's a subscription-based cloud casting service that Topcon offers, where you can actually set a base rover up and have the base broadcast corrections over the internet using our Magnet Relay cloud casting service. It would require 2 subscriptions, one for the base to broadcast the correction over the internet, and then at the rover for capturing that correction and applying it to the solution. That is about 1 centimeter or so horizontal and vertical. So Magnet Relay, that's lastly your RTK solution that you can use for hybrid positioning. So why do we want to use hybrid positioning? It is our most productive positioning tool that makes us very unique. Our hybrid positioning tool offers a complete game-changing workflow so that you can switch from GPS to robotics and back again, depending on the terrain, depending on the environment, what sort of conditions. And it is absolutely amazing. It is very exciting to have a tool that permits you to instantaneously and on the fly switch out and use what the best tool is for what you're measuring. The rod with the current GNSS equipment and magnet field, it is the lightest weight hybrid pole and the most cost-effective way to implement both GNSS and robotics. And in combination with the magnet field and enterprise, it is the most innovative and productive tool for data collection and exchange. So what we're doing is we're simultaneously connecting both robotic and GNSS data flow and allowing for switching between both technologies depending on the environment, job site requirements, and the obstructions that there may be that prohibit you from using whichever sensor you may be using, whether it's GPS and lack of view to the sky, or using your robot and lack of view to the instrument from where you're working. And so that's the neat thing about magnet field and using hybrid. We have a button, one button quickly switches to either one of the solutions that's right for you and that application. The GNSS positioning, you can press one button and it will have basically a dog whistle, have the instrument come faster to you than any other way to get the instrument to reacquire a lock. We call it a dog whistle. It is amazing. By the time you press the button to get hybrid locked and utilize the GPS to have the robotic come to you, you could look up from looking down at pressing the button, and that instrument is on you before you can even look at the instrument. It is that fast. And so another use for this is using your GNSS equipment to localize an optical project on top of Bing Maps. Basically, we're going to see Jim a little bit later on do a back sight, orientate the instrument, and just simply shooting the first 4 points in the survey topo screen, it is going to create a localization automatically, and it does it pretty slick, and it will let you know when you have a localization. And that is a very nice way so that in the future, when you look at the projects you've done with your robot, it will let you map out those local projects on a Bing map or in Magnet Enterprise if you use that to store your projects for field and office applications. That is a perfect way for you to be able to view projects that you only thought maybe you could do it because they're in state plane, but we're localizing using your GNSS equipment, all your local projects as well with hybrid. And for the similar price of your RC units that you may have on your variety of different older robots, it does give you the flexibility to have GNSS measurements available to you while you're using your robot at any time the site calls for switching over from robotics to GPS. So some of the reasons why hybrid positioning is so beneficial. Well, you know, while you're out with your robotic instrument and you get around a building and you don't have any more view to the instrument, switch to RTK, one button press, and it will get all of those shots without changing the occupied point. Shooting control, moving the total station, a lot of those things are taken out of play when you don't have to because of you having hybrid positioning. It saves so much time putting the equipment away, your GPS equipment, let's say, to go pull out the robot and then back and forth again. If you can't get a first floor elevation inside a building with using RTK that you've been using, switch to robotic mode, have the instrument come to you and get the shots with no visibility to the sky of those finished floors. Walk behind the range of, beyond the range of Bluetooth communications with your robot, get beyond 800 feet, 1,800 feet, 2,800 feet from the communications to your robot with whichever way you may be communicating with your robot. Switch to RTK, extend the range out of that optical setup. I just had a client last week talk to me about exactly that. They had just gotten a brand new hybrid system. They went beyond what the instrument could do, trying to get some shots along the street, and switched to the GPS, and they got it. They smiled at one another as they went on about their business and utilized hybrid for the first time. So you can't get shots at the edge of the field or canopy environments with your GPS. Switch to robotics. Get the shots with obscured view to the sky. Even urban canyons and those sorts of things, besides the environmental conditions that generally fence lines and section lines, they're very challenging. So if you have the robotic available to you, press the button, hybrid lock it to you using the GPS position to a degree. You may have to search for it just a little bit because maybe the GPS is in a float solution or a autonomous solution. You should still be able to get it close enough to hit the search button, and utilizing the horizontal and vertical angles that you can put in for its search, have it lock on and start working in those challenging conditions with the robotic. For contractors using a hybrid system where on a job site there's continual construction traffic in the way, switch to GPS when you can, and you'll find that it is a tremendous benefit in respect to offering up the ability to get positions with construction traffic. You go under a bridge, let's say you're doing a road survey or what have you, and you're using GPS, use robotic mode. All of the shots that you need to measure or lay out under a bridge can be done in robotics. So some of the terminology that we're using, hybrid switch, that is the terminology used to switch between GNSS and robotics with one button click. And as you can see on the illustration there, you will always have either the GNSS receiver icon or robotic display, depending on what sensor you're actually using at this time. And switching will also change the menus to a degree, especially in setup, to reflect what sensor you have and what type of setup you can do with each individual sensor. Whether it's the GPS or robotic, you'll see the setup screen be appropriate for the piece of equipment or the device that you're using. Hybrid lock. Well, this uses the 3D GNSS position to be the dog whistle to call the instrument to you. The other illustration we have, it's basically a magnifying glass that when you're using hybrid and you have it set up, that will no longer be grayed out. You will have access to one button press and it will come to you within a second. It is incredible and require lock. No searching needed. So the next step, the next one of our technologies that we have a terminology for is hybrid resection. So since you're using your RTK and your robotic at the same time, your RTK is offering a position if you have your configuration, especially set up in state plane with the geoid model, all of the parameters there to where you would typically use a network rover in that fashion, where you have your datum and your coordinate system, your geoid model all established. So you can just simply, walk out and use it. Well, in a hybrid resection, since you're using state plane, you can just basically go do a resection, and as a hybrid resection, it will permit the data collector to go from robotics to GPS without even pressing a button other than to measure the robotic angles and distances. It will switch automatically to GPS, and using basically 3 points around where the total station is, will resect in the total station and give you what the residuals are to your resection. You can accept that or not and try it again, but it will give you the results of that resection and how well it is. And then lastly, hybrid localization. Basically, you can use the GPS positioning information to localize a project right on top of Bing Maps in the projection or localization selected in the project parameters. Basically, what you could do is start your job with 5,000, 5,500. Set the instrument up on that point, orientate yourself using direction, and then go about shooting 4 points and see that localization come up automatically, thus giving you a positioning in the local coordinate system. So in the configuration of magnet field for hybrid, when we go into connections, we have our survey connection here, and this screen here shows one when you're not using hybrid, you'd have to select GNSS or optical, and you see the parameters below where you can connect a last Bluetooth device and prompt for connections at startup. But up at the top in the left there in the general tab, we have a box that says hybrid positioning. It is the box that you would check mark, and the magnet field software will permit the controller to hook up to the GPS and the optical both at the same time. If the configurations of your survey are not appropriate, that will be grayed out. It will not let you connect hybrid because one or the other configurations is irrelevant, and you must go take a look at your configuration. And it has to be a robotic instrument for your optical. It has to be basically a network or base rover solution as far as the option for your GNSS equipment. So also the hybrid box is also going to have the prism offset and the GPS offset calibrated to your rod. So by check marking that, it is going to automatically take into account your hybrid adapter difference between the bottom of the mount of the GPS and the center of the glass. And I think that at this stage here, we're going to see a little video from Jim. So I'll hand it back over to you, Jim.
Thanks, Mark. All right, let me show this video. So I went out in our parking lot here at the Olathe office of Topcon and did a hybrid resection and a hybrid localization and just did some screen recordings of everything I did. So I'm going to play this. I'm going to kind of narrate it as we go, explain what I'm doing, pause a few times here and there. So I first set up a job and magnet field called hybrid resection. So key thing here is I had an optical configuration of a GT1203, and I called it 1203 hybrid because I don't have an RC with it because I'm using the hybrid lock. And then a pretty much standard Hyper VR network rover. So the first thing I want to show is the coordinate system. In working with a hybrid resection, we want a state plane coordinate, and using state plane coordinates with magnet, you want NAD83 no transfer your datum, and then just a geoid model that fit in this area. I'm not using grid to ground right now, but you certainly can, and that will correct your total station shots and scale them appropriately, so you are collecting true state plane on everything. I was just lazy and decided not to check that box. So then I want to show the connection. This is what Mark just showed a moment ago, that I've connected up in hybrid positioning. Yes, I got a big mouse here. I'm not really blind. I just want everyone to see it. And I'm doing hybrid. It knows it right here. I'm connected. I'm getting network corrections right here. I've got connected to both the robot and the GNSS receiver. So now I'm going to go right up here. I'm switching back and forth. I don't know if everybody saw that, but this right here is the hybrid switch. So all I do is click on this button. I'm currently in robotic mode. If I click it again, it'll show that GNSS receiver. Sometimes we call it the hamburger. And that'll tell us that we're in GNSS mode. So I just switched from GNSS to robotic right up here. And now we're going to go into our setup. So I'm doing a resection. And this is a standard robotic resection at this point. I have no points in my job right now. I'm going to give my occupy instrument point, just a new point number. And I'm lazy. I just want to call it point number 1. So I called it point 1. I didn't give it a code. I measured up at 5.3. Now I'm ready to shoot my control point. Now this is where it's a little different than a standard resection. Normally you'd walk up to a known control point. You'd load that known northing and easting information into the job, and you'd say, I'm occupying this point. Here we have nothing. Again, there's nothing in the job right now. I'm going to go to just some random location. I can have an actual point on the ground, but it doesn't have to have known coordinates in the job. What's going to happen here is when I store it, I will store the horizontal angle, the vertical angle, and the slope distance from the robot. In the very next step, it'll do it automatically. It's going to store the northing, easting elevation from the GNSS receiver based on the projection that I have. So I'm going to put in a point number 2 here because I just want to call it point 2. I'm going to hit the button over here in the corner to store the shot. Or first, I'm going to walk to the point and get the instrument locked up on me. So I'm taking the shot, and it immediately goes right to the storing of the GNSS screen. So now I'm storing the GNSS data for the exact same point, hitting the buttons right down over here. And now I'm ready for my next point. So now I'm walking to the second resection point. And in my case, I just walked, a little bit to the east. I think about a couple hundred feet. I wanted to have a good resection geometry. So my points far apart, but not too far apart, a good angle between them. And I did the same thing again. I called it point number 3. And then I shot and stored the robotic data, and then stored the GNSS data. And it immediately pops up. Here's all my parameters for my resection. Pretty good. Not great, but I wasn't being all that critical. But I'll take 4 thousandths and 18 thousandths right here. So this is my resection, and I can either accept it, or I could add more points and go shoot more. I could remeasure a few of them. I can move some out, just like a standard resection. But I'm going to go ahead and accept it. And then I move on, and I'm ready to start topoing. Now, remember, I am in robotic mode right now. But yet, if my background map turned on, it knows right where I am. It has the geodetic coordinates. Everything is tied geodetically because of the GNSS receiver that's going on in the background, storing all that data. So I've got a good resection. Now I'm ready to start collecting data. So I'm in true state plane coordinates at this point. The next thing I want to do is I want to go ahead and collect this island right here. So I'm going to walk over to it. I'm going to turn my background map off just because it kind of gets in the way for me sometimes. Here we go, turning the background map off. Just going in. There is a shortcut button you can do. I just didn't have mine turned on. So now I'm going to collect that island. And so the first thing I'm going to do is do an EP. And since I'm collecting a line, I'm calling it EP1, and I'm starting at the arc. So I'm going to do an arc start. And then I'm just taking the shot, hitting the shot button in the lower right-hand corner. Store it. Now I'm going to walk to halfway through the arc. I'm going to take the next shot. I'm going to walk to the end. This is a compound arc, so I'm going to do an arc end and arc start. So I'm going from a small arc to a big arc. Take the shot. I walk a little bit. It loses me. It's going to find me again when I walk behind the tree. I'm going to store the middle of the of the larger arc. And there it's got it. I'm going to go to the end of the arc, and I'm going to do an arc end. Take the shot. I'm going to walk the long line of the island. I'm going to switch to GNSS mode. So if you notice right here, I'm in robotic mode. I hit that button. I've switched to GPS mode, and now I'm going to do an arc start as well because I'm getting ready to start another arc. Take the shot. It's just continuing along. I'm going to take the middle of the arc. Take another shot. I'm going to do another arc end and arc start, going from a big arc to a little arc. I'm going to walk to the middle of the arc, take the middle shot. And I'm going to walk to the end. I'm going to switch from GPS mode to robotic mode. I'm going to do a arc end and close. And I've collected that entire island, switching from GPS to robotics and back, all collecting the same coordinate system. So I didn't have to close out, go back and forth. It was just one button switching back and forth. So now what I'm going to do is I'm turning the instrument off of me away. And then I'm going to do right here. This is the hybrid lock. So I'm going to hit this hybrid lock button and have it turn back to me and lock on. So I hit it. It's turned right to me. It's going to lock on the prism. And boom, I'm ready to start working. So I'm going to do it again, but I also took a little iPhone video of the thing turning to me, so that should switch over here in just a second. So I'll turn it off of me, and here's the video. If you watch the instrument there, and I've clicked, it turns that fast, and then locks onto me. And then I'm ready to start working. By hitting hybrid lock, we're telling the instrument the horizontal angle to turn to and the vertical angle to turn to find the prism. So it's using all the GNSS data to do that. It's different than our RC unit from the way it works. So that's our hybrid lock, and that is our hybrid resection. Now I'm going to do a hybrid localization. So this is a little different. I'm creating a new job. A lot of times you just want to work in a local coordinate system, 5,000, 5,000, and go. So, but how do we use GPS with a 5,000, 5,000 system? Well, we use a localization. So that's what I'm doing here. I'm creating a job called hybrid localization. And then one of the key differences, I'm changing my projection to none, and I'm turning off the geoid model. I've just got nothing out there. Now, I do need to set the instrument up over known points, but I'm just going to call it 5,000, 5,000, and I'm going to orient to east. And so here I'm loading in my single point. No geodetic coordinates with this thing, just a random 5,000, 5,000, 100, or 1,000. Then my next step, I know this is going kind of fast, guys, so we're running short on time. I'm going to go right into the backside routine. I'm telling my occupy point is that point 1 that I chose. I'm backsiding east because that just happens to be the direction I want to face. I walk to roughly east of the instrument. I have the instrument still locked on me. And then I just turn off the measure distance and hit set. So just to orient the angle. Now the next thing, I'm going to go right into a topo. So I'm just going to start collecting data. Now I got to remember, I am doing a localization at the same time. So I don't want to just take 3 shots that are 2 feet apart. So I'm calling it a CP point. But it really is, these are just random points. There's nothing actually in the ground. I know nothing about these points. I'm just shooting them as topo points. But I do know that since this is establishing my localization, I want them around the perimeter of my project. So I'm zoomed all the way out right here, but I'm actually kind of walking a bit and going to take 3 points around the outside so I can establish a good localization geometry. So it lost me there, just about got to my point. I'm just going to take another shot. Stored it. So it looks like it's just storing robotic data. But in the background, all the GNSS shots are being stored as well, all the GNSS data. And you know, I'm still fixed right here. This is what this button right here tells us, that I'm still fixed. So now I've got to move to the other point, and I think I get interrupted right in the middle of this recording. So it'll lose me for a second. It's going to start searching. I walk behind a couple of cars, locked it back onto me, told the person coming up and talking to me to leave me alone so I can get this job done. which never happens on a job site, right? So now it's got me. I'm going to store this one, and that's what I want to show you. As soon as there's enough data for a localization, you'll get this hybrid localization was updated. And so essentially we have done a localization. We have GNSS data on every point. We have northing and easting data on every point, because the northing and eastings are based on the instrument occupy point and our backsite location. So from there, I can turn on my background map. So turn on my Bing background map, and it's going to load. Takes just a second. And now with robotic data, local robotic data, we are geo-referenced. This is the Topcon headquarters here in Olathe where I'm at. So now I can go and just start collecting data. And just like I did in the last one, it lost me. I'm going to move a little bit and do a hybrid reset, or a hybrid lock. So it's searching while I'm walking. I'm like, all right, stop searching. Here's the hybrid lock. Come to me. I'm right over here. It's going to lock on me, and then I can just start taking topo shots. So now I'm in robotic mode. I'm just going to take some ground shots. Let me start taking some shots here. Move along. Take another shot. And then I'm going to switch to GNSS mode here in just a second. There we go. See, I'm now in the hamburger right up here. So now I'm in GNSS mode, but still in the same coordinate system. I'm still on that 5,000, 5,000 based on the instrument setup. And I just keep right on collecting. So that is the hybrid localization, a little different than hybrid resection. But in both scenarios, you essentially start off with nothing. You've got no known control points. In both ways, you've got good, accurate geodetic data on the back end, and accurate robotic information on the front end, and the hybrid lock works perfect. So that's pretty much our video. Let me close this out. And we did have one question emailed into us beforehand, so I want to answer that one. The question, let me get it pulled up here real quick. I have to find it. Here we go. So Dale had asked, if I start a job with an existing state plane file, so I'm assuming everything is in true state plane coordinates, and I resect off existing monuments due to tree cover, very common. So you're in state plane coordinates, and the two existing monuments are in state plane. You set your instrument up back in the trees. You shoot out to those two so you can bring your state plane data inside the trees. As I make my way through the trees, I come to an open area and switch to hybrid. Is there going to be any position adjustments from hybrid off the original setup with the instrument? And the answer is no. As we showed a moment ago, you can switch back and forth with no problem. There's no positional shift. Because you are tied together and you've got a hybrid resection, it works perfect. So any other questions, Diana, that popped up at all?
We don't have any at this time, but just as a reminder for anyone that does have a question, feel free to insert those into the questions pane, and we'll get to those here as we still have a few minutes.
Absolutely. So if anybody's got anything, we'll watch for that. I want to thank everybody for attending this. We just got a couple minutes left. Amazing that we hit it right on the, almost right on the dot. If you got any questions, you can email us at info@topconsolutions.com. There's our new national number for the Topcon Solution Store. See a question just popping up, and for some reason I can't read it. What's it say there, Diana?
It says, what is the name of the product that you said could make a GPT 9003 compatible with hybrid?
Yes, so it is the communication of getting them back and forth. You can actually, and we can provide these, it's a little Bluetooth radio dongle. that has to have a battery on it and a cable that goes from this little dongle up to the instrument. Little other settings you got to do on the instrument to tell it to communicate via that Bluetooth dongle. But then on the data collector side, it's just a Bluetooth connection. So our long-range Bluetooth FCs or SHCs will work perfect with it.
And another thing on that 9000 that we're talking about, that will power the dongle as well. So that's one of the instruments that you can utilize the battery power in the robot to power that long link Bluetooth dongle we're talking about.
Perfect.
Okay, there are no more questions at this time. Oh,
Awesome.
just kidding. We do have one more if we have time for one more.
Yep. Read that, Taylor.
Okay. So can I export a hybrid localization to Pocket 3D, or do I need to localize separately with Pocket 3D?
The answer is yes, you can export that localization and bring it into Pocket 3D. I would always double check it. Sometimes there's a little vertical shift that can be corrected fairly easily. But yes, you could do because it is a standard localization. At the end of the day, it's just a localization. It's the same as if you were to shoot them all with a robot, put the robot away, take the GNSS out, and localize to it. Our hybrid simply does it all in one step. So just as if you would do any other localization to export out to Pocket 3D, a hybrid one would work as well. Thank you so much. We really appreciate you taking the time and watching our webinar. And please give us a call if you got any other questions.
Once again, thank you very much, and glad you guys could attend, and look forward to speaking with you in the future. Reach out to any of the Topcon Solution stores regarding knowing more information and have a rep contact you. And we'll be happy to come out and show it to you at your particular location.